Hello and welcome to the Unit 12 review. This is the last review before your last test of this class. The Flipped Math 1, it's coming to an end. That's pretty neat. And congratulations for making it this far. For the first set of problems here, we're dealing with parabolas. We're dealing with quadratic equations. And what we want to do is we want to start off with a bunch of different steps. We're going to state the vertex, state the axis of symmetry, state the roots, and identify the domain and range. Okay? There's a lot of things to do, but we covered a lot of things based on the graphs of quadratic equations or of parabolas. Okay? We're going to start off. I'm going to do number 3 for you. Okay? Let's go ahead and look at what we're doing here. So I want to start off with the vertex. And the x-coordinate of the vertex equals negative b over 2a. All right, and so negative b would be negative 12 or positive 12 over 2 times 1, which is 2. So 12 over 2 is 6. Now, if you remember what I did from here is I'm going to go ahead and make my t-chart, my table of values, starting at 6. And I'm going to go 7, 8, and 9. And what I'm going to do now is I'm going to plug them into a calculator and see what we get. Okay, I'm going to input the equation that we're using into the calculator, and this is with a very basic calculator, but it works pretty well. All right, so we have 6 squared minus 12 times 6 plus 32. Now, again, the reason I put things in parentheses, that's the number that I'm going to change to make all the values of my table of values there. So hit enter. Okay. Let me double check that that's right. I think it is. Okay. So we get negative 4. So at 6 it's negative 4. Let me make sure I added 32. Yeah, I did. Okay. So we get negative 4 there. I'm going to plug in 7 now. I'm going to plug in 7. I get negative 3. And when I plug in 8, so you see how quick it is to change the numbers that you're using. So at 8 I get 0. And let's see what we get at 9. At 9 I get 5. Alright, so that was a lot of work, and I haven't really answered all the problem or all the pieces of this yet, but I'm going to go ahead and do most of that now. So the vertex is at 6, negative 4. The axis of symmetry is at x equals 6. So let's go ahead and graph that now. We need to find the root, so we need to find where it crosses the y-axis. So x equals 6 is right here. And we know that that really important point is at 6, negative 4. And then we're gonna work our points over here, and we're gonna mirror them over the axis of symmetry. So at 7, it's negative 3. At 8, it's 0. And at 9, it's 5. It's about right there. Okay, let's go ahead and mirror those over. So it takes me 1 unit to get there. So I go another one, 2, 2, and 3, 1, 2, 3. And now I can sketch that graph. Even though, ironically, in the directions, it doesn't even say to sketch the graph. I think it's implied when I give you that nice coordinate plane there. Remember, show me effort, try to make a smooth transition, smooth change of direction, and make a graph right there. Okay? Now talking about roots. So C says state the roots. And it looks like it's at 8 and 4. So x equals 8 and x equals 4. Okay? And then part D talks about domain and range. Domain, we get all reals. Okay? All reals for the domain. We can use any x value we want, but for the range, the range starts at negative 4 and goes upwards. So y has to be greater than or equal to a negative 4. Okay, and so that's all the parts of that question, and it's done pretty well, and it didn't take us that long to do it. So it feels like a lot of work, but it's really not. Okay, let's look at the next page. So for the next page here, we're going to start off by solving the quadratic equations by taking square roots and expressing our answers in simplest radical form. Okay, so we're going to look at number 8. Now for number 8, all I really want to do is solve for the x squared and then take the square root of both sides. So I'll add 3. And we get 7x squared equals 525. All right, we can divide by 7. And x squared will be, that's going to give us 75. So now I want to take the square root of both sides. So when I do that, I get x equals plus or minus, don't forget about that part, and the square root of 75. Why did I put 5? 75. Okay, and then we want to simplify that if we can. 75 splits up into 3 and 25, which splits up into 5 and 5. 5 has an exit buddy, pull that out in front, we get x equals plus or minus 5 square root 3. Not too bad. Okay, let's look at the last section here before the application problems, and I want to do, let's go with number 13. So the first thing I want to do is I want to get all this stuff over to the other side and just 0 on the right hand side. So when I do that, I get 6n squared. I'll have to add the 7n to both sides, and I'll have to subtract the 143. And that's going to equal 0. Now for the great song. So opposite of b plus or minus square root of b squared minus 4ac all over 2a. And we can replace those with numbers now. So the opposite of 7 is going to be negative 7 plus or minus 7 squared will be 49 minus 4 times 6 times a negative 143. Wow, that might be a big number. All over 2 times 6, which is 12. Okay, let's go ahead and simplify that square root. I'm going to use a calculator for that, just to get a better idea of what we're going to get here. So I'm just going to plug in that whole thing, that 49 minus 4 times 6 times negative 143. So I get 3,481. I'm going to go ahead and take the square root of the answer. Yeah, that's a little trick with the calculator to plug in what you just got as an answer. And it gives me 59. So really what we have here is negative 7 plus or minus 59 over 12. Okay, that's one of those cool answers, because what ended up being under the square root was a perfect square. A very big perfect square, but still a perfect square. So from here, I'm just going to go negative 7 plus 59 equals, divide that by 12, and I get 4.3 repeating. So we get 4.3 repeating, and for my other answer, I'm going to go negative 7 minus 59, and divide that by 12, and we get a negative 5.5. So those are my two answers. So I think that you are more than equipped to do the quadratic formula on the rest of these problems. Okay, let's go ahead and look at the application problems, and we'll get out of here. For the first of the application problems, it's that vertical motion model. We've used that in the last section also. So, in this case, we're talking about shooting a rocket that goes 82 feet per second initially, and it starts at 3 feet high. Okay, so it's asking us, after how many seconds does the rocket reach its maximum height? So when you look at the graph of this, not that we would graph it, but it's going to be something like this. It's going to look kind of like this here, where this horizontal axis over here is time, and the vertical axis is height. Okay, so when they're talking about the hint being the x-coordinate of the vertex, how many seconds will it reach its maximum height? That would be right in the middle, the vertex. Okay, that's what we're looking for there. Number 2, what is the maximum height of the rocket? So there you're finding the y-coordinate of the vertex. So we found the x-coordinate and the y-coordinate now. And we've done that before, just finding the vertex. Remember, the x-coordinate is negative b over 2a. And then you plug that in. I'm going to say s of negative b over 2a. Just meaning that you plug that in for t in the formula right here. Okay. The next one says, what does s of t equals 0 mean in terms of this problem? That one, sorry, you're just going to have to think about it. If you need help after you've thought about it for a while, go ahead and ask me and I'll give you some hints. Okay. Next one uses the quadratic formula to find out when the rocket will hit the ground. Okay. So here you're going to answer in decimal form. So just use a calculator once you figure out what needs to go where. The next one's saying, what does s of t mean? Or sorry, s of 3. What does s of 3 mean? And then I want you to find s of 3. Okay, and that means something specific in this problem. Don't just say it means you plug in 3 for t and see what you get. Give me an actual thoughtful sentence answer there. Okay. The next 2 problems are totally disjoint from the problems before. We're not talking about that bottle rocket anymore. We're just talking about a couple special problems. So the rectangle has a perimeter of 140 inches. So write an equation. If you remember, perimeter equals 2 times the length plus 2 times the width. Okay? And so you'll plug in the length and width in there and write that equation. Then you can solve it. Okay? And the last one, the rectangle has an area of 240 inches squared. So area equals length times width. Okay, it kind of looks like a square, but I don't know if it's actually a square. So don't assume it is. Just go ahead and plug in your length and width. It doesn't matter which one's which, as long as you keep it straight in your head. And so write an equation to model it and solve for y. Okay, I'm guessing you're going to solve those by taking square roots. All right. So good job on all the reviews, all the sections. Okay, soon to be all the tests and mastery challenges. Okay, I hope you guys had a good time. I know I did. And again, make sure you're asking for help if you need it. But I think you guys making it to this point means you're doing pretty well. So congratulations. Give yourself a pat on the back and get that last test done. Talk to you later.